The Engineering Gold programme features chemical engineer Professor Peter Styring. Peter is also a skiing coach. The programme outlines the research he has carried out, leading to the development of a self-waxing ski, which could help Great Britain win gold at the Winter Olympics. The programme addresses several areas of the How Science Works curriculum, including practical and inquiry skills and the collection and analysis of scientific data.
Professor Styring's film gives us a really great context for looking at data, and the activity where students test out their own lubricants is very useful because it gives them first-hand experience of how difficult it actually is to get reliable data.
The nature of this morning's investigation is going to be to try and investigate the ways in which we can make skis go faster. We're going to begin by showing you a DVD of a scientist. He's a very local scientist, I'm proud to say. In fact, his work takes place just down at Sheffield University. There's a lot of information, and all of it is absolutely relevant to what you're going to be doing after.
As you can see, it's now starting to move just a little bit more.
But this isn't just an opportunity to sit back and relax.
What you see here is that for
Just going to pause that briefly and explain what the results are showing. We had on the x-axis the number of runs, so we had run 1, run 2, run 3, run 4, run 5. Up the side here we've got time in seconds, so the higher it is, the longer it takes. So if you were to look at the graph, we've got red line and blue line. What's happening to the red line? The time taken for the skiers to come down the mountain. Yeah, so Matt?
Time for the skier with the lubrication will be lower, so the red line will go down if that's the one with the lubrication.
Great, okay, that's right. So we've got a difference between the two skiers there. So, yeah, our red line decreases with on the tests. We've got a couple of blind tests he talked about without lubrication at all, and then they stick lubrication on and you'll see the graph dip right down. The time it takes for the skier to get down the track is much less. And interestingly, when you look at the other line, the skier without lubrication, what's happening to the time it takes them to get down the track through the morning while they're doing this testing? Yeah, Danny?
Well, the more through the day it goes, the slower he got.
Right, okay, so they're getting slower through the day. Probably things are changing on the track, more sun on the slope, snow's getting softer. Okay, but there's a difference in there. Right, okay, if we roll that again and have a look at those results and see if you can pick them out.
When the teacher showed students the film, he paused it at several points. One of those points was when the graphs came up. And that's really crucial because they show some very significant results.
Bring the stools out.
Having seen Peter Styring's film, the pupils are introduced to their inquiry. The teachers draw on their own skiing experience to enrich the context.
There you go. So, when you're skiing, you have to put lubricant on the bottom, otherwise you just stick to the snow, especially when it's quite wet and it's been a warm day. So, as a skier, one of the things I would do is I'd have some different waxes and I'd mess around with the amounts of these waxes I put on my ski. Now, you know, I use an iron, this might be like extreme ironing. So you melt some of your wax onto your ski, some of the white wax, that's for hot temperatures, some of the pink wax for really cold temperatures below sort of -10. Iron that on there, so you've got lots of wax on the ski. And then once that's dried and solidified, then scrape that off so you've got a nice smooth surface. And then you sort of buff that up and then your ski's ready to go down the run. So you've seen the old style of waxing skis to make them go faster. Your job today is to look at how you can use some other lubricants, and Mr. Davies is going to talk to you about these, how you can use those with your ski to make it slide down the slope faster.
This is a ski.
The equipment might be a little more basic, but the intention is the same.
In the setup, the teacher also explained the parallels between what the students were doing and what Peter was doing, so it made the whole process feel more real.
The teacher also uses some time during the inquiry introduction to reinforce some of the scientific knowledge they feel the students may need to draw on as they develop their inquiry.
So your two chemicals are oil and water. There's a problem. Can anybody envisage a problem of mixing oil and water?
They separate out.
They separate out. Any example in the kitchen cupboard of where that's a problem? Where we might see it possibly in the fridge?
Mayonnaise.
Mayonnaise. Oh, isn't that where oil and water actually?
Yeah, but that's because they use an emulsifier to hold them together.
Ah, fantastic, yeah. So, what does an emulsifier effectively do? Connor?
Makes an emulsion.
Okay, by doing what?
By having a hydrophilic and a hydrophobic end which attach to each, the fat and the water, which creates an emulsion.
Brilliant answer, far more than I was expecting. I was expecting, oh, it makes oil and water mix, but no, we've actually got a thoroughly scientific explanation. Brilliant answer. So there's going to be an exercise where you in your group are going to be doing an interpretation of what you've seen, and then ultimately, the dreaded word, but essentially evaluation. You're going to be then asked to evaluate it. Are there any questions before we start? Okay, Nikita?
Do we have to clean the board after every time, or just leave it with all the stuff on?
Everybody got an objective view on that? Should we wipe it off or should we leave it? What do you reckon? We got an answer? Yes.
Well, I think we should wipe it off, because otherwise, if any's left on from the last one, it's going to affect the results on the next one.
Yeah, I reckon. We're expecting you to have possibly 5 formulations, cunningly labelled A to E. You're going to decide on what those formulations are going to be. We want you now, in the next hour, hour and a half, to arrive at a position where you have come up with a formulation that you would be able to recommend.
Well, the teacher set the activity up in quite an open way. So the students were given some structure, but he actually gave them some time to do some preliminary work to start with. And he gave them permission, almost, to not know quite what they were going to do. So they felt as though they could use some of their time to play with the equipment. So they felt comfortable that they weren't expected to know immediately how to carry out their inquiry.
Being given an open activity allows the students to ask, what if? Some have the novel idea of testing the setup without any liquids as a starting point.
What was your control? What do you mean by control?
Well, we didn't have anything on the board, so we were just doing a test.
So without lubrication?
Yeah.
And what height did that start sliding at?
We did 2 tests, so we've got 10.5 centimetres in it.
Okay, great. So, okay, do your third one then, and then you can get an average result.
The way in which the teacher set up the inquiry, he emphasised to students that they should feel free to do some trialling, some preliminary work.
4 parts water, 1 part detergents has been more effective than 4 parts oil, 1 part detergent. An equal balance of oil and water with some detergent to hold them together, and more oil than water. So it looks as though water is more effective than oil for lubrication. I was expecting the oil because you generally associate oil with slipperiness, and we use oil in cars to keep things fluid and lubricated.
They're thinking about the experiment critically as they're doing it because it is their experiment, and they feel as though they have the right to change it, if you like, as opposed to being given an experimental method.
At the beginning, it was a bit low at the start, so we got 15.5.
So we questioned that.
Yeah. So then we started to put the lubricant on, and it got higher to like 31.3. So we did no substance again, and it went to 22 centimetres. So we're wondering, so we did a double attempt then.
But we think that was because there was already substance that we couldn't wash off on the board.
It's all very well setting up open activities and encouraging students to take ownership of their research, but in most classrooms, time can be an issue.
I think teachers are sometimes put off by open-ended investigations because they think it's going to take a lot of time. The key is to plan so that the introduction and the follow-up are quite tightly structured, and the time is given to the most important part of the inquiry, which is where students are developing their own ideas.
Another concern might be that an open activity could leave less able students floundering.
It's always a balance, though, between making them feel confident that they're supported enough and have enough structure to be able to push themselves that little bit further, and leaving them enough space to develop their own ideas. So all of the activities that are associated with the films come differentiated.
And when the students are supported and confident, they deal better with unexpected results.
it doesn't move because it's stuck. So it's an unfair, it's an outlier really.
Maybe if we use less, it's more likely to slide.
Is there another programme which is the best sticking? Because we'd be really good at that.
Students are often looking for a yes or no, black and white answer. And one of the things that their own inquiry work enables them to appreciate is that just because their lubricant didn't seem to work didn't mean that they had a bad experiment. One of the things that the students really started to appreciate after their experiment that their individual group results didn't make a great deal of sense to them. It wasn't until they pooled their results, so they had more replication of data, that they started to see some patterns. And the other thing that this activity gave the teacher an opportunity to do was to show students that there are statistical ways of judging whether there's a real difference between data sets. So whether one lubricant was really different from another, and the way in which that you can look very closely at your data to make that interpretation.
The teacher extends pupil understanding of the limitations of data by discussing with them whether their data appears to show real differences between the lubricants.
One thing you may have seen on the DVD, on one of the graphs that Mr. Cook referred to specifically.
Point in the middle and then a bar.
Yeah, what we often have is it's a thing called a range bar, and it's really good. Now, some people find it hard to understand the significance of that. So if I had a series of results, let's say, and my averages, let's say for argument's sake, were that, I might conclude, oh, that looks pretty good, best fit straight line, I feel happy with that. But if you actually put your full range, not your average, but if you could in some way represent all the results on there, then we get the whole range on the graph. So, for example, if I found out that my results actually, for each run, was something much more like this, for example, I may feel less inclined to feel as confident about this line. So we might, see, so now I'm showing a range of results, and it's good because it gives us a better flavour for each run. Just showing averages and then from that a best fit line isn't always as informative to the people that we're trying to inform. Let's consider another situation. If, again, I'm just referring to three sets of results, there would be another obvious concern if we ended up with a situation like this, again, just making stuff up. Not only might I think they're rather regular, it would never be unlikely we conduct an experiment with that, but just for the purposes of this, you may say, well, average of those, that, best fit line, fantastic, job's done. But of course, it seems rather odd that there are a significant number of these results that overlap with the ones that came before it. Now, that would make me feel much less confident about the validity of what I've done. Okay? So, again, the way in which we interpret data is always going to be significant, a fairly perfect term. Again, coming back to that, I think that difference at this stage, with only 3 results, I'd call them the same. If after doing it 500 times for 5 years, like Professor Styring did, if that was coming out as that difference repeatedly, then I might think, well, it's small, but it is significant.
But say if, like you got, so if that was your line, then you got some results here, but then one like freak one, like down here, would you bother including that in the range?
We'd refer then to that as an outlier, and we may decide to test that one again. We may, yeah, what basically is saying is if we had this situation, let's just, here's another example. Imagine, for example, we had this situation where our results were like this, okay, just making something up quickly. So if we had something like that, now I might feel confident that my average, much tighter. A result like that, it would be silly of me to say, oh no, that error bar, huge. Obviously, we can feel why that's wrong. What I want to do is go back and try and work out, was there something my partner did, or me, that led to that. And we'd refer to that as an outlier, because if we can't ultimately explain that away, then we might choose to refer to that as an anomaly.
The open-ended inquiry approach appears to have been a positive experience for pupils and teacher.
This lesson's been quite good, I think. It's been quite fun. We got quite slippy and quite messy, which is always nice, because we haven't had a lot of control today over what we do, whereas often in practicals they kind of tell us exactly how to do it, so it's been a good one today.
It was great this morning to be able to give them a free rein, within some limits of course, but to allow them to get stuck in, and they rise to the challenge every time. So often we do things within constraints that make them find it so formulaic, they just are following instructions. But today they really rose to that challenge to find things out and to take some kind of ownership over their results.
For other activities related to this programme, please refer to the curriculum materials.